Welcome to the Explainer. Today we're diving into something really cool, the official playbook for the next 10 years of space exploration. Think of it as a blueprint that takes our biggest, wildest questions about the cosmos and turns them into actual missions. So, how do we, as a species, even begin to decide what to explore next? I mean, you've got a whole solar system, billions of galaxies. Where do you even start? Well, it turns out there's a plan. And in this explainer, we're going to break down that very blueprint, the strategy for tackling the biggest mysteries in our solar system and way, way beyond. Okay, so let's get into this master plan. And I want to be clear, this is not just some wish list of cool places to visit. Nope, this is a super carefully thought out roadmap, and it's built on the consensus of hundreds, literally hundreds, of the world's top planetary scientists. The whole thing is called the Decadal Survey, and it's been going on for over 60 years. The National Academies basically gets the entire scientific community together to forge a consensus on where we should point our rockets next. So, yeah, it's way more than just a report. It's like the ultimate mission briefing for NASA, for everybody. And this is a really important point. This whole thing isn't just about building bigger and better rockets. The entire plan, every single mission, is driven by pure curiosity. It's all about answering those huge, fundamental questions we have about our place in the universe. Bottom line, the science always comes first. All right, so let's get to the why behind it all. How do these questions actually build the roadmap? Well, the whole strategy is built around three main themes. And honestly, they're pretty much the three biggest questions you could possibly ask. First up, origins. Simple as that. We're talking about looking way, way back to the very beginning. How did a spinning disk of gas and dust eventually become planets, moons, and, all the stuff needed to create life? The next big question is all about how these worlds got to be so different. I mean, why is Mars a frozen desert, but Venus is this crazy runaway greenhouse? It's that question that pushes us to figure out the forces that shaped, well, everything, from the rocky planets to the ice giants, and even those beautiful, complex systems of moons and rings. And then, of course, there's the big one, the ultimate question. Are we alone? We're trying to figure out the exact recipe that allowed life to pop up here on Earth, and then, and this is the exciting part, could that same recipe exist somewhere else? This is it. This is the search for life, whether it's here now or was there in the past, somewhere beyond our own little blue marble. Okay, so we have our big questions. Now, let's look at the incredible missions, the actual expeditions we're planning to get the answers. And we're talking about the highest priority flagship missions for the next 10 years. All right, priority number one. The top of the list for a new mission is a trip to one of the most mysterious and, let's be honest, kinda neglected planets in our solar system, Uranus. Can you believe we've only had one quick flyby? And that was way back in 1986? It is definitely time to go back for a proper look. So the plan is to send what's called the Uranus Orbiter and Probe. It's going to do exactly what it sounds like, orbit the planet and then plunge a probe deep into its atmosphere. It'll check out the planet's weird interior, its magnetic field, and explore its 27 moons, some of which might even be ocean worlds. But here's the kicker, the really cool part. Planets the size of Uranus are actually the most common type of exoplanet we found out there. So this mission, it's not just about Uranus. It's about getting the ground truth to understand literally thousands of other worlds. Next up on the priority list is a mission that could be a total game changer, a search for life on Saturn's moon Enceladus. Because of the Cassini mission, we already know Enceladus has a global ocean under its ice. It has energy, it has organic molecules, it checks all the boxes for life. We know it's habitable, so the next logical question is it inhabited? The mission concept is brilliant. They're calling it the Orbalander, and it's got this really clever two-step plan. First, for about a year and a half, it'll just orbit Enceladus, flying right through those plumes of water erupting from the hidden ocean, literally tasting what's coming out. Then it's going to land on the surface for a 2-year stay, searching that icy material directly for signs of life. But hey, this grand vision isn't all about the outer solar system. It also lays out some really ambitious new goals for our closest neighbors, the Moon and Mars. The idea is to use them as these incredible windows into the past and as labs for finding life. And what's cool is that these two worlds offer totally different but equally amazing opportunities. You can think of the moon as a history book. It's preserved this perfect record of the early solar system, a record that's been totally wiped clean here on Earth by geology and weather. Mars, though? Mars is all about the search for life, past or present. It's our #1 suspect. So, to read that history book on the moon, the survey is pushing for a mission called Endurance A. And this is where things get really cool. It's this amazing blend of robotic and human exploration. You'll have this toughest nails rover driving for thousands of kilometers across this giant ancient basin, collecting about 100 kilograms of diverse rocks. And then it will literally meet up with Artemis astronauts, hand over the samples, and they'll bring them back to Earth. How awesome is that? Now, over on Mars, things are going to shift. Once we, hopefully, get the samples back from the current Mars Sample Return campaign, the focus is going to change in a big way. We're going to go from looking for signs of ancient life to searching for life that might be there right now. The mission is called the Mars Life Explorer, or MLE, and its strategy is super straightforward. Go where life could actually be hiding today. So it's going to land in an area where we know there's ice just below the surface. Then it will drill down, maybe up to 2 meters, deep enough to get below all that harsh surface radiation. And it will analyze those icy samples right there, looking for any signs of biological activity. And finally, it's important to see that this 10-year roadmap isn't only about looking out into the cosmos. It also brings all this incredible exploration right back home, connecting it to our own survival and progress here on planet Earth. A huge part of that is planetary defense, and there's a really clear 3-step plan for it. Step 1, find them. We need missions like the NEO Surveyor to find and catalog any potentially hazardous asteroids. Step 2, characterize them. Once we find one that's a bit worrying, we need to be able to launch a quick mission to figure out what it's made of. And step 3, divert them. We need to keep developing and testing ways to actually push an asteroid off course, just like the DART mission proved we could do. It's a real, workable system to protect our planet. And the report makes one thing crystal clear. None of this happens without people. Achieving any of these incredible goals means we have to tap into our greatest resource, which is people, the full diverse range of human talent and new ideas from every background imaginable. So there you have it, from the icy, tilted world of Uranus to the hidden oceans of Enceladus, all the way to the frozen ground beneath the surface of Mars. This roadmap is setting the stage for what could be a decade of just mind-blowing discovery. And it leaves us with this incredible, thrilling question. In 10 years, which one of these discoveries is going to be the one that changes everything?